question today that tests you on your ability to identify the use of the binomial theorem difference of squares in this question. So a lot of times the SAT is not going to come out and say, hey, use the binomial theorem difference of squares. You're going to have to be able to identify that that applies in this situation. So what does it say? It says, okay, this expression is actually equivalent to x plus b. So in this case, anytime I see a fraction, it's pretty annoying to me. So one thing that you can always do to clear fractions is to multiply both sides of the equation by whatever is in the denominator. So here, if you multiply both sides by x minus b, then this would cancel out on this side. And on this side, you would get x plus b and x minus b. So this is where in your brain, if you've studied the binomial theorems, it should go ding ding ding, this is difference of squares. So there's nothing really that mysterious about difference of squares, it's really just FOIL. So if you've used this acronym in math class, it just stands for first, outer, inner, and last, and that's just how we kind of expand through our binomials. And so if we've done this so many times, you can remember certain patterns that can help us really quickly cut through the algebra. So over here, a squared minus b squared, this is where you get difference of squares. This one is going to break down into x plus b, well, actually for this it would be a plus b, a minus b. And so when we see this pattern repeated over here, you can effectively replace this with what it would be in terms of difference of squares. So this, in this case, it would just be x squared minus b squared. So if we know that x squared minus c is equal to x squared minus b squared, then what do we know? Effectively, this c term will be equal to our b squared term. So this is not really that enlightening, but what it does say is that c is a perfect square. So in other words, it is a product of a number multiplying itself. And the only option here is going to be 4.